Here's an example of an Ethernet Powerlink system. A 9030 P3U4B0 controller is connected to 3 Aries EPL drives. This 9030 has 4 access connectors and 2 25-pin D-sub connectors, which has 12 onboard discrete inputs as well as 8 high-speed inputs and 4 discrete outputs. These I/O can be wired syncing or sourcing. It also has an auxiliary 9-pin master encoder input. If it was a 2-axis 9030, it'd also have the 20 inputs and the 4 out. For the 6 or 8 axes 9030, it'd have twice the I/O, so 40 inputs and 8 outputs, as well as 2 secondary encoder inputs. This is the same for the ACR9000. The Aries PE drive's 25-pin D-sub connectors have 7 discrete inputs, 3 of which are high-speed and also 4 discrete outputs. They can also be wired NPN or PNP. The Parker I/O module is connected to the 9030's CAN open port. This allows analog inputs and outputs as well as more discrete I/O. With the Ethernet TCP IP port, it is communicating via Ethernet IP with an express HMI. Here's an example of a 9040 system. Again, the 9040 controller is connected to an express HMI via Ethernet IP. The Parker I/O is connected via the CAN open port. 3 Aries PE drives are connected as well. The 9040 doesn't have onboard I/O, so limit switches or I/O can be connected to either the Parker I/O or the Aries PE drives. If you had a standard quadrature master encoder on the machine to connect, it could be wired to the high-speed inputs of one of the Aries PE drives. Only the A channel and B channel would need to be connected. These inputs do not need to be reprogrammed and automatically take the incoming pulses in and transfer them to a numeric parameter to the EPL controller for gearing, camming, etc. Note the 25-pin D-sub on the Aries PE drive does not have a user power supply, so the machine's power supply would need to be used for limit switches, encoder power, etc.